Welcome all to the SD online classes. This is chapter 3 continuing from the previous video number 16. This will be our 17th video. The topic here will be heating effects of electricity. In this chapter, we have done electricity introduction, electrostatic potential, potential difference, resistance, numericals based on them, electric current itself, then Ohm's law, direction of current, electric circuit, resistance combination, series and parallel, unit of resistance, rheostat, resistivity, that is specific resistance, its formula, and some solved examples based on the resistance formula, and some numericals on the series and parallel combination of resistances with their derivation itself. Okay, so the next topic is here, heating effects of current. Okay, this is the definition of heating effects of current. It is basically that in any of the object, once we pass electrical energy through any source, the electrons inside that, the movement earlier was free electrons movement, that will be disturbed. Okay, when that is disturbed, it will cause heating and some other changes as well. This will lead to the heating manifestation. You will see heat is generated, and that is called heating effect, and it is also called Joule's heating effect. Okay, this is the heating effect of current. Now, what is the cause? What is the reason? Now, the causes of heating effects of current is like this. When you connect potential difference means a battery is applied across any metal or conductor. I am telling in very short. Force will be generated by some chemical reaction inside the cell. You know that inside the cell there is cathode and anode, positive and the negative. From there, electrons will start moving. During this movement, the electrons will collide because on the way they will find positive ions of the lattice atom. In the lattice arrangement, there will be atoms. This will create extra increase in the kinetic energy. Why? Because when speed will be generated, velocity will be generated, kinetic energy will increase of the atoms. This vibration of the atoms will be drastically increased. This will be shown out. We will observe that, we will feel that the heat is giving the rise in temperature. So this is called heating effects of current. Okay, in short, you can understand like this. Now the next topic is how much heat is produced by electric current. Is there a connection? Suppose I give 5 ampere of current, how much joule of heat? Heat is energy. So now electrical energy is converted into heat. So how much of the electric current will give you how much of the heat? Is there a formula? Is there a way that we will try to derive? For this, we will first put a working condition here where current is flowing, resistance is there, and heat is generated. All this we have to assume. So that we will do now. We start it by making one resistance here symbolized as R. This resistance will be connected with a battery. Why? Because we need potential difference. This is positive side of the battery, this is negative side of the battery, and this is the circuit. This resistance can be anything which will be generating heat on it. Now the current will flow from plus side to minus side. I flow through the resistance out and it will come back like this. Let us write what we have taken. Let R is resistance, I is current. Okay, and what is remaining here? Q is the charge and T is the time for which charge flows. Okay, for this we assume there is one resistance current is flowing from this resistance and the charge is Q here, capital Q. The potential difference, that is the battery, is connected here. Current is flowing like this. Let R is the resistance, I is the current, Q is the charge, and T is the time for which this charge is flowing. Now I need to find how much heat is here. Heat will be probably symbolized as H. Okay, so whatever we know previous of our knowledge about resistance, current and time, we'll try to derive how much is the heat energy. Now we know already that the relation between charge, current and time. So what I'll write here is Q equal to I into T. The dot means T. Why? Because since current definition is charge divided by time, so cross multiply it, Q equal to I into T. Okay, you already know this. 1 joule is how much energy? 1 joule is the work done. Energy and work done are the same here because work done is the same unit having joules. Okay, so we will try to come from here to the work done, and that much work done we will write it as energy later. Okay, that is the trick of doing this. 1 joule is the work done in moving 1 coulomb. There is some relation for the charge and potential difference to the work done, that is in the potential topic we have already done. Okay, 1 joule is the work done in moving 1 coulomb of charge through a potential difference of 1 volt. Okay, if it is so, what we can write it here is W is the work done will be equal to potential difference V into Q. Here I have to write W stands for work done and V stands for potential difference. The symbol is like this. The third symbol Q is, we already know, it is charge. Okay, so this is the work done, potential into Q, right? Now the energy produced will be E equal to W is equal to V into Q, because work done is also energy. This much energy can do that much work. Okay, so that is why W and E will be same. If W and E are same, E will be equal to V into Q. Okay, we keep these things safe now and go on replacing whatever we know. Okay, the energy, this energy appears, means we can observe or see or feel as heat energy, because after all it is a process of conversion of energy. Electrical energy is converted into heat energy. So that is why this energy H is equal to work done is equal to, okay, what is that? V into Q. Now this energy E appears as the heat energy, and hence H can be written, H is the heat energy, can be equal to W equal to V into Q. We already know what is Q. Q is here I into T. If you observe here, I into T, so we will replace it here. So this will be H equal to, and right implies here, V into I into T. What I have done here is we have written Q equal to I T replaced. Okay, now this is the H equal to V I T is the equation of heat produced by this current and by this potential difference for this much time. Now you can change this into many other things also, like H equal to, if I write in place of V as IR, because V equal to IR is Ohm's law, V is equal to IR, so I can write it, then I into T. This will become, this can become H equal to I square RT. This is another formula for heat produced. Okay, VIT in terms of potential difference, current and time. In terms of current, resistance and time, this is the one. Okay, another way of also there to write I, okay, and what I'll do here, V I will keep as it is, and I will replace it as V by R, again Ohm's law. Here I can understand I can be replaced as V by R into T. So this will give me H equal to V square divided by R into T. Okay, so this is also another way. This way, main formula is VIT. You can remember this as the easiest one, and replacing I square RT, when depending on if the voltage is not given, current and resistance given, you can use this. If the current is not given, voltage and resistance given, you can use this. Okay, remember, all everywhere T is there, right? So this is the expression for heating effects of current, or Joule's law of heating effect. Okay, Joule's